I had somebody ask me recently, do breakers actually put out power? Like, is a 20 amp breaker providing 20 amps through a circuit? And the answer is no. A lot of people have weird misconceptions. A lot of non-electricians will say, think that these breakers are somehow controlling and like putting out a certain amount of current flow through a circuit, but what really all they are is they're detecting too much current. So every breaker is going to be rated a certain amount. On the handle, you can see this is a 2-pole 20. So if we have like a 220 circuit, we would use a 2-pole 20. Or if we have two single pole 20 amp circuits that share a neutral, we would have to also put a common handle tie. So either way though, the 20 on here represents the maximum amount of current that this thing's designed to handle before tripping. That's 100% of its current rating. Now for breakers to trip, they're basically safety devices. So if more than 20 amps starts flowing through here, it shuts the circuit off. That's the intent. So a load is always going to dictate how much current is flowing. So if we were to plug like a floor fan or something into a receptacle into this, the floor fan might draw like 10 amps, we'll say. So only 10 amps is flowing through this 20 amp breaker. Everything's cool. But say we plug another one in. Now it's 10 amps plus 10 amps. We've got 20 amps flowing through this. It could trip. Some breakers are designed anywhere from like 100 to 130% roughly. If there is an overload, or if there's a short circuit, there's two different ways breakers trip. So from about 100% to 130% of whatever this handle says, if like a motor gets bound up, or if there's just slightly too much current flowing through the circuit over a certain amount of time, it'll develop a lot of heat, and that's called a thermal trip. So there's a thermal trip mechanism inside of here that will, over a little bit of time, eventually trip it. If you got like 24 amps or something, you might have 24 amps flowing through the wire. If you put your clamp-on ammeter around a conductor, it might have 24 amps, but it's a 20 amp breaker, and you're like, why is it not tripping? Because it's going to trip up to 130% of that value for an overloaded circuit. A short circuit is a very different thing. Short circuits, when you have like a hot and a neutral and you touch them together, boom, that's an explosive amount of energy. It's an insane amount of current. So in a situation like that, there's a magnetic trip mechanism inside of breakers as well. So if it's 200% or more, up to a certain level, it can be like 200 to 300%, because some breakers actually have adjustable trip mechanisms and things like that. Every breaker is designed slightly differently, but if it trips at about 200 to 300% of its rating, that's supposed to be for short circuits. So short circuits, since there's no load, there's no resistance in that circuit. So a lot of current's going to flow through that circuit. So basically, all of that to say, these don't put out anything, they're just switches. So essentially, you can think of an electrical panel as a large junction box, but instead of wire nuts, we're putting breakers, and we can manually turn things on and off, and treat these like switches, or we can use them as safety devices. So if there's too much current, there's 30 amps on that 20 amp breaker, it's going to trip. So it's not putting out anything, it's stopping things from putting out too much. So hope that answered your question. I love your guys' comments. Please leave comments below if there's any other video ideas that you like. If there's anything else about breakers specifically, please leave comments below. Love you crazy people, and I'll see you next time.